Okay, for this question, we are given that a random sample of 34 light bulbs had a mean life of 435 hours with a standard deviation of 23 hours. So we would say here the standard deviation is 23 hours. Construct a 90% confidence interval for the mean life mu of all light bulbs of this type. So notice that this is what we do with confidence intervals all the time, is that we have a sample, and in this case our sample has sample size 34 because we chose 34 light bulbs, and then we notice that their mean life x bar, because it's for the sample, it's x bar, it's 435 hours. And the standard deviation for our sample, S, was 23 hours. So now what we are asked to do is to construct a 90% confidence interval. So the confidence level should be 90%. So this is the confidence level. Okay, so one thing that you know when you solve these questions is you need to find z sub alpha over 2 from the beginning. That is the critical value for 90% confidence. I will remind you quickly how to do it. So you have the normal distribution here, and you want 90% confidence, so you take the part here and you say that this has area 0.90, which is 90%, and then you want to find z sub alpha over 2, which is this point here, the z value here, and in order to find it you also need to know the area of this little part that is on the left side. So notice that this part, because you took already 90%, you have 10% left outside, so this will be 10% divided by 2, which will be 5%, so it will be 0.05. So this will mean, let me put just this here, this will mean that the probability or the area to the left of z sub alpha over 2 is equal to the 90% that we have plus the 5% to the left of it, and this would give you 0.95. And this, if you look at the z table, so I will just remind you this, you use the z table here, but please watch parts 1, 2, and 3. They will make you do this very quickly. So you will see from the z table that z sub alpha over 2 for us in this case is going to be 1.645. And this is the most important part of your calculation, because everything else is just a formula that you apply. So now we will say the first step is computing z sub alpha over 2 for 90% confidence, and we found that it's 1.645. That was our first step. Now our second step is to compute the margin of error E, and this is just z sub alpha over 2 multiplied by the standard deviation divided by radical sample size. And if you do this computation, notice that z sub alpha over 2 is here, s is here, and n is here. So if you do this computation, you'll get 6.5 approximately, approximated to just one digit after the decimal. And the last part is to write the confidence interval. You can say, therefore, my 90% confidence interval, in this case, is going to be the sample mean x bar minus the margin of error, the sample mean plus the margin of error. And so you remember, what was the sample mean? It's given here. It's 435. So this is going to be 435 minus the margin of error, which we just computed, 6.5, comma, 435 plus 6.5. And so if you compute this, I'll put it in black, it's going to be 428.5, comma, 441 98.5. So this here is our 90% confidence interval. Okay, and I will just write my conclusion here. Like, what do we conclude from all of this? It's important to know it, even though we're done with the solution. But you can say, therefore, we are 90% confident that the true mean of all light bulbs of the type that we are checking, so that mu, this is the true mean for all light bulbs of the type that we are checking, is inside the interval. You can say inside the interval, which is 428.5, 441.5. So this means that mu, this mu here, is going to be inside this interval, and we are 90% confident of this statement. So it means that mu is going to be bigger than or equal to 428.5 hours and less than or equal to 441.5 hours. And this will answer this question, and we'll finish our 4-part questions on confidence intervals. I hope that by now you understand it much better than before you started watching the videos. And I will stop here.